Okay, so why would we need to know the angle sum and difference identity? Well, the angle sum and difference identity helps us find the exact trig values of angles that are not on the unit circle. We're going to take the sine sum and difference identity and we are going to use it to find values that aren't on the unit circle. It says below, find the exact value of the sine of 15 degrees using two angles from the unit circles whose difference is 15. Now, notice 15 is not on the unit circle, but let's think about special angles whose difference would give me 15, meaning I have two angles that are on the unit circle. If I subtract those two angles, then it would equal 15 degrees. And if I think about it, what I'm going to look at is this 5 here. That's going to be an indicator that one of the angles I'm dealing with is 45 degrees, right? And I just got to think, what other angle could I subtract that's on the unit circle from 45 to give me 15? And the only angle I can subtract from 45 to give me 15 is 30. So I know my two angles are 45 and 30. And because we're talking about difference, I would be using this difference formula. So we're going to substitute for angles A and B 45 minus 30. And that's going to give us the sine of angle 15 degrees. So I'm going to say, hey, the sine of 45 minus 30 is equal to the sine of 45. Notice I've just substituted in 45 for angle A. Cosine of 30. Notice I just substituted 30 for angle B. Minus cosine. Gotta go back. Put the wrong letter. Cosine of 45 again, just substituting 45 degrees for angle A, sine of 30. Now, because these two angles are on the unit circle, we can then find their trig values by going to the unit circle, looking at their terminal points, recalling that at their terminal point on the unit circle, the x is going to be the cosine, the y is going to be the sine. So for 45 degrees, we know that terminal point is radical 2 over 2. So my cosine is going to be radical 2 over 2. My sine of 45 degrees is radical 2 over 2. Same for, and I don't have it labeled, but same for 30 degrees. If I go to the unit circle, the terminal point is radical 3 over 2, 1/2. So I know the sine value is 1/2. The cosine value is radical 3 over 2. I can just substitute those values into this equation because I know I've gotten them from the unit circle. So let's simplify this. 45 minus 30, well, that's just 15. And it's going to be equal to the sine of 45. Well, we know that's going to be radical 2 over 2 times the cosine of 30. We know the cosine of 30 is radical 3 over 2 minus the cosine of 45, which we know is radical 2 over 2, times the sine of 30 degrees, which we know is 1/2. Now from here, let's go ahead and simplify this equation. I'm going to take and multiply both the fractions, both sides. So I'm taking radical 2 over 2 times radical 3 over 2. Remember when we multiply, we just multiply straight across. So this would be radical 2 times radical 3. Well, that is going to be radical 6 over 2 times 2 is 4. Minus radical 2 times 1, well, that's just radical 2, over 2 times 2 is 4. And then to just simplify this, I know that I have to have a common denominator when I'm adding or subtracting fractions. They both have the same denominator, so they're going to be over 4. And then I can just put their numerators together. So I know the answer to this is radical 6 minus radical 2. And this is the exact value. I have not used the calculator. So that is the exact sine of 15 degrees. Let's use the same thing, and we're going to find the exact value of the sine of 285 degrees using two angles from the unit circle. This time it says whose sum is 285. Sum means addition, so we're going to use this formula up here. We're going to say, let's first come up with our angles. So some angle plus another angle is going to give me 285 degrees. And I said the hint here is when you see that the 5 at the end of your angle, you know one of your angles are going to be 45. Okay, so we just have to find the other angle. So what angle could I add to 45 to get 285? And I know I can just add 240. So 240 plus 45 would give me 285. So I got my two angles. Let's go ahead and substitute them into the formula. For angle A, I'm going to put 240. For angle B, I'm going to put 45. So I'll say, hey, the sine of 240 plus 45 is equal to the sine of 240, which is angle A, times the cosine of 45, angle B, plus the cosine of angle A, which is 240, times the sine of angle B, which is 45. We already know the sine and cosine of 45 degrees because we already found it from the unit circle. Let's think about 240, and this is a quick one. Remember, 240 is actually going to fall somewhere here in quadrant 3. And the quick way to know it is to just think about what the reference angle is of 240 degrees. And that means that we're going to calculate this space in between 240 and the x-axis. And if we think about it, from 180 to 240, to get there from here to here, that space in between is 60 degrees, which means that the sine and cosine of 240 is going to be exactly the same as 60 degrees. The only difference is we're going to have a different sine value. Both the values are going to be negative because this is in quadrant 3. So we know the sine and cosine values. Well, the cosine is negative 1/2, and the sine is going to be radical 3 over 2. and they're both going to be negative. All right, let's go ahead and plug those values in. The sine of 240 is negative radical 3 over 2 times the cosine of 45, which is radical 2 over 2. Okay, just pulling that off the unit circle, plus the cosine of 240, which is negative 1/2, over the sine of 45, which is radical 2 over 2. And now I'm going to just simplify everything. I know that this is equal to the sine of 285 degrees and with my fractions, remember, I'm just going to multiply straight across. Negative radical 3 times radical 2 is going to be a negative radical 6 over 2 times 2 is 4. And a negative 1 times a radical 2 is going to be a negative radical 2. So I'm just going to change this. This will be a minus because that plus then will change to a minus. So this would be a negative radical 2 over 2 times 2 is 4. So my final answer is negative radical 6 minus radical 2 over 4. We'll go to the next video and get some more practice using the sum and difference formula.